Hello viewers, welcome to Step by Step. So today I have a geometric progression question which reads, the first three terms of a geometric progression are 3p, 5p plus 5, 8p plus 20 respectively. So the first question is show that p squared minus 10p plus 25 is equal to 0. Part B of the question says, hence show that P is equal to 5 and find the common ratio of this progression. And C says, find the sum of the first terms of the progression. Right. So the first step is you need to know that to calculate the common ratio, we want to show that P squared minus 10P plus 25 is equal to 0. So we just have to calculate the common ratios, then we equate the common ratios, because here we can find two common ratios simply by saying 5p plus 5, which is the second term, divided by the first term, or the third term divided by the second term. So for a geometric progression, R is either the second term divided by the first term, or third term divided by the second term using the information that is given. Right, so R will give us 5p plus 5 divided by 3p, or R is equals to 8p plus 20 divided by 5p plus 5. Right, so we equate the two. 5p plus 5 divided by 3p is equal to 8p plus 20 divided by 5p plus 5. Afterwards, we cross multiply the two. 5p plus 5 multiplied by 5p plus 5, this denominator multiplied by the numerator, and this denominator multiplied by the numerator. So we get an equation in P, which is 5p plus 5 squared is equals to 3 multiplied by 8p plus 20. Right. So now that we have gotten the equation, we want to solve that equation. That is when we can show that p squared minus 10p plus 25 is equal to 0. Right. So if you expand this, you will get 25p squared plus 50p plus 25 is equal to 8 times 3, which is 24p squared plus 60p. Right, then afterwards you collect like terms, so it is 25p squared minus 24p squared plus 50p minus 60p plus 25 is equals to 0. So if you solve that one, you're going to find out that your answer will be p squared minus 10p plus 25 is equal to 0. It's shown. It's shown. As simple as that. So now that we have done part A of the question, part B of the question reads, hence show that P is equals to 5 and find the common ratio of this progression. Okay, P squared minus 10P plus 25 is equal to 0. So this is a quadratic equation. We want to find the value of P. So we multiply the first one and the last one and we get 25p squared. Then we find factors which when multiplied they give us 25p squared, but when added they give us minus 10p. So the factors are minus 5p and minus 5p. Afterwards we rewrite the equation putting the factors, so it becomes p squared minus 5p minus 5p plus 25 is equal to 0. We did this so that the expression becomes factorizable. So here p is common, we factor out p, and here minus 5 is common, we factor out minus 5. So the new expression becomes p multiplied by p minus 5 minus 5 by p minus 5 is equal to 0. Therefore, p minus 5 squared is equal to 0. And our value for p is equals to 5. This is shown again. So let us not forget the next part of the question, which says find the common ratio of this progression. So to find the common ratio of this progression, it's now simple. R is equals to the second term divided by the first term. So you choose the R you want to use. You might use the third term divided by the second term. But for the purposes of this tutorial, I used the second term divided by the first term. If you use the third term divided by the second term, it's still going to give you the same answer. So we now substitute the value of p to get the value of R. So p is equals to 5. So we go and substitute 5. P with 5. Wherever there is p, we put 5. So it becomes 5 multiplied by 5 plus 5 divided by 3 multiplied by 5. So if you evaluate the top, which is the numerator, it's going to give you 30. And the denominator is going to give you 15, which means that R is equals to 2. So we have answered the second part of the question. So now we have P is equals to 5 and R is equals to 2. So now we move on to part C of the question, which is the last part of the question. And it says find the sum of the first 10 terms of the progression. So to find the sum of the first 10 terms of the progression, we have to use P. We also have to use R. So the formula for calculating sum to n terms of the progression is equals to A multiplied by R to the power n minus 1 divided by R minus 1, where A is the first term. In this case, it is 3p. R, it is the common ratio, which is 2. And n, in this case, is the number of terms, which is 10. The number of terms that we want to calculate for is 10. Okay, so here we don't have the value of A. That is the only thing that is constraining us to calculate the sum to 10 terms. Right, so A is equals to 3p. So 3 multiplied by 5, we substitute p with 5. So A is equals to 15. Right, so we go and substitute into the formula to find S10, sum to 10 terms, which is 15 multiplied by 2 to the power 10 minus 1 divided by 2 minus 1. So sum to 10 terms is equals to, of this progression, geometric progression, is equals to 15,345. So thank you for watching, guys. I hope you enjoyed the video. Please consider subscribing, and may you kindly share our videos to family and friends who might need our help. Thanks once again. Till we meet again.